Let's take a look at this PowerPoint presentation with also a couple of equations, and I also have a Word document over here. So transformations of functions, just a few things that we did see in class. If we wanted to go ahead and see vertical shifts, let f be a function and c is a positive real number, then if you have y is f of x plus c, it will be the same as the graph of y is f of x shifted c units upward. If you have y is equal to f of x minus c, then it will be the same as the graph of y is f of x shifted c units, this time downward. So let's illustrate that with two equations. If you have y1 is x cubed and y2 is x cubed plus 2, take a look. Let's say we say f of x is x cubed, that's my main function over here, and we have g of x is x cubed plus 2. Notice x cubed right here is really f of x, so we can write g of x as x cubed. Let's place f of x instead of that and put the plus 2 afterwards. So that's another way to look at it in terms of the writing. Now if you were to plot those two curves, let's say y is x cubed, which is f of x is x cubed, that's my function y1, my first function. Let's compare it to y2, which is g of x, which is x cubed plus 2 or f of x plus 2. Notice I have two different patterns over here. For y1 I have a thin graph, which I'm going to even try to make dotted over here. Let me see if I can dot this over here. There are different patterns you can choose. I'm going to go with the dotted pattern, which is even contrasting more with the y2 function. Let's go ahead and graph those two, and let's go ahead and take a look. This is x cubed and this is x cubed plus 2. Notice the function y is x cubed went through the origin at 0, 0, and the other one is cutting at 0, 2 for the y-intercept. So you notice that really there's a shift 2 units upward for each point. It does look like the graphs are touching each other here. You have to realize there are some limitations to the calculator, and also because we use a thick pattern for the second curve, it looks like the graphs are touching, but they're indeed not, because each point is moved 2 units upward, so they're not going to be touching those two curves. If x cubed plus 2 takes the graph 2 units upward, you can only imagine what would happen if I say x cubed minus 2. Now let's take a look at if f of x again is x cubed and h of x is x cubed minus 2. Then h of x is x cubed minus 2. Notice x cubed is now in green over here, and just to remind you, that's another name for f of x. So h of x is, instead of just saying x cubed minus 2, you could rewrite it as f of x minus 2 over here. So let's take a look at how those two graphs are comparing to each other. Again, x cubed, the main graph, will be dotted, and the new graph of x cubed minus 2 will be in bold over here. Let's take a look. So here goes x cubed to the origin, and the other graph is 2 units below. As you can see, it has a y-intercept of 0, negative 2. So that's what we have. So let's just recap over here. If you have y is x cubed and you have over here the function y is equal to x cubed plus 2, then it will take your graph 2 units upward. If you have x cubed minus 2, it will take your graph 2 units downward. Let's now take a look at horizontal shifts. F is a function. If we have y is the f of the quantity x plus c, then it's the same thing as the graph of y is f of x, but it's shifted c units to the left. And if it's y is f of x minus c, then the graph of f is shifted c units to the right.